Welcome to number 27 in Richard James Mathematics Resources. This one is entitled Maximum and Minimum of Quadratic Expressions. Most natural and man-made systems can be approximated or properly represented by the use of mathematical expressions. The expressions may show how certain attributes of the system vary with or are related to each other. There are many reasons why extreme cases may prove to be very important. A person may want to maximize revenue. In the case where the amount acquired may be a constant value, one may want to minimize the amount relinquished. Worst case scenario may prove to be detrimental, while best case scenario may prove to be highly favorable, among many others. Throughout your career as a mathematician, you will gradually learn to find extreme values of expressions. At this stage, we will begin with those that have 2 as the maximum power of the variable used. Those expressions are called quadratic expressions, and the curves associated with them are called parabolas. As you progress to higher levels, relative maxima and minima will be introduced, because curves keep rising and falling in an interval rather than getting to a maximum or minimum value only once. Another stationary point called point of inflection will also be introduced. In the meantime, have some fun as you prepare for greater things in the not so distant future. We are going to be looking at the maximum and minimum by completing the square. This might be a strange word. It is going to be used mainly by mathematicians. This word extremum is a word that is used to describe both maximum and minimum, or just the extreme point, which of course may be maximum or minimum. Before attempting to find the maximum or minimum of a quadratic expression, and of course we're going to be doing that by completing the square, the following will demonstrate the fundamental principle on which it is based. We have a variable mass here being added to a constant mass, and we are going to be examining what is going to happen to the total mass. In the diagram, the 2 containers on the left side of the equal sign represent the mass of the contents of 2 containers. The one of constant mass has a fixed mass of 20 kilograms. There we have the constant mass that will not change, 20 kilograms. The one of variable mass has its mass changing all the time, but its minimum mass is 0. So the one of variable mass has its mass changing all the time, but its minimum value is 0. Presently, the value of the variable mass is 0 kilogram. What is the total mass? Total mass, of course, is 0 plus 20, which is equal to 20 kilogram. Let us show the sum of the masses for different values of the variable mass. So we have the variable mass right here and the constant mass right there, and what is going to happen to the total mass. When it is 30, 20 plus 30 is equal to 50, and of course the constant mass remains 20 kilogram. Variable mass is 40 kilogram. When they are added, 60 kilograms, and of course we are going to put 0 kilogram right there added with the 20, and we have 20 kilograms. 90 kilogram plus 20 kilogram, and that is equal to 110 kilograms. Notice that the smallest value of the total mass is equal to 20 kilogram, of course, and that value is also the value of the constant mass. So the smallest value of the total mass, let's see if we can find it right here, and it is equal to the same value as the constant mass. This minimum value occurs when the value of the variable mass is equal to 0. This is how it will be with the quadratic expression. The type that has minimum value will have that value when the variable part is equal to 0. So be mindful, do not forget that the minimum value of the total mass is going to be equal to the constant mass, and it is going to be equal to 20, or has its minimum value, when the variable mass is 0 kilogram. So let us see if we can rehearse it a little bit. The total mass is going to have a minimum value of 20. That's the total mass, a minimum value of 20, and that is equal to the value of the constant mass, and that value is going to be consistent with the value of the variable mass being equal to 0. And that is what our next section is based on. So now we should all be familiar with the process of completing the square that was discussed in details in volume 2, and volume 2 is functions part 1. We will therefore not bother with the details here, so we are not going to be bothering with the details of completing the square, although we are going to go through the process. The first two terms will be used to generate the perfect square and are therefore placed in brackets. So we have these two terms placed in brackets right there. The third term of the perfect square is formed by taking half of the middle coefficient and squaring the result. The middle coefficient is 10. Half of 10 is 5. When we square 5, we get 25. Notice that everything that we have here has some representation above. This 25 is a newcomer and was not there before. We therefore need to get rid of the 25 from the entire expression by subtracting 25 in the end. Now this is the perfect square that we have inside the bracket, and that is equal to x plus 5 all squared. And the constant values we have here, 13 minus 25 is equal to a negative 12. The resulting expression has two parts like our introductory masses. We have the variable part of the expression right here, the variable expression, and the constant value. What is the minimum value? The variable expression is over here as we had it before, and the constant value is here. And remember, the variable portion may change its value because of the presence of x. X is present in this portion, so it is variable. That means its value will change. The value will change because x can change. So as the value of x changes, so does the entire expression. Then we have our constant value right there. So let us examine the value of the variable part of the expression for different values of x. Notice that here we have x plus 5 all squared. The value of x is changed to 4. 4 plus 5 all squared, that is 4 plus 5 is 9. When we square that, we get 81. And another value for x, 2. 2 plus 5, 7. When we square that, we get 49. And another value, 0. So 5 squared is equal to 25. And of course, we have negative 2. So 5 minus 2 or negative 2 plus 5, that is equal to 3. When we square 3, we get 9. This time, negative 3 is added. So we have a negative 3 plus 5 is a positive 2. When we square that, we get 4. So x plus 5 all squared again, and we are replacing that x with negative 5, so we get 0, and we square that and we have 0, and we have some other values right there. Notice that the values of x include positives and negatives. Notice also that the result is never negative. It decreases to a minimum value of 0, then start to increase again. So we see 81, 49, 25, 9, 4, 0 going down, and then we start to increase again. So a perfect square we have on this side, and the value is never negative, even though the value of x that is used on a few occasions will be negative. The expression, the entire expression, is never negative. That is, the entire variable part of the expression is never negative. The final result never gets negative because it is a perfect square. The value of a perfect square is always positive. Therefore, the minimum value of the variable expression, being a perfect square, is 0. Can you remember what the total mass was equal to when the variable mass was equal to 0? The total mass was equal to the constant mass, and it turned out to be the minimum value of the total mass. The minimum value of the entire expression is equal to the constant value of negative 12. So this is going to be the minimum value, which is a constant value. Another very important consideration is the value of x at which the minimum occurs. Remember that it occurs when the variable part, which is the perfect square, is equal to 0. So the perfect square, which is the variable part, is equal to 0, and that is going to give the minimum value of the expression, and the minimum value of the expression is going to be equal to the constant value. So by looking at the list on the left, we should be able to determine that the corresponding value of x is negative 5. Therefore, the minimum value of the expression is negative 12, and it occurs when x is equal to negative 5. Therefore, the minimum value of the expression is negative 12, which is the constant value, and it occurs when x is equal to negative 5, and that is when the perfect square part, which is the variable part, is equal to 0. We will not always have a list to consider, and it will be a waste of time to try to construct one in every single case. The value of x corresponding to the minimum value may be found by solving a simple equation. X plus 5 all squared minus 12. X plus 5 all squared minus 12. The variable part is equal to 0. So x plus 5 all squared is equal to 0. Means that the content of the bracket is equal to 0. So if the variable part, which is x plus 5 all squared, is equal to 0, it means that the content of the bracket is equal to 0. That is, x plus 5 is equal to 0. So if x plus 5 is equal to 0, by solving this simple equation, we get x is equal to negative 5. The content of the bracket is always a simple expression that will result in a simple linear equation that we may solve in our minds. So let us take a look at another expression. In completing the square, the coefficient of x squared should be equal to 1. So we factor off the 2, and the negative 12 is also affected. So as usual, if the details of completing the square cannot be grasped at this stage, then there's an entire topic on it in Volume 2, Functions, Part 1. Next, we need to square half of the middle coefficient. Squaring half of 6, we get 9. 9 is a newcomer to the expression. We therefore need to subtract it at the end. But the 9 that we have here is multiplied by 2 in front of this bracket. So instead of putting a subtract 9 here, we put minus 18, which is, of course, 2 multiplied by 9. Of course, negative 7 minus 18 is negative 25, and we have the completed square. The constant value is the minimum value of the expression. It occurs when the expression inside of the bracket is equal to 0. So solving the equation x minus 3 is equal to 0 gives x is equal to 3. Therefore, the minimum value of the expression is negative 25, and it occurs when x is equal to 3. In completing the square in this particular case, the coefficient of x squared should be equal to 1 also. So we factor away the 2, and the 5x is also affected. So 5 is not a multiple of 2, so we divide by 2. So we have 5 over 2 right there. Now we're going to take half of 5 over 2, which is 5 over 4. When we square 5 over 4, we get 25 over 16. And we need to subtract that 25 over 16 at the end. However, the 25 over 16 is being multiplied by the 2 right here. So if they are multiplied, 2 will cancel with 16, and the result is 8. So we are actually subtracting 25 over 8. Now we have negative 3 minus 25 over 8. And as we have been doing in quite a few subtopics throughout Richard James Mathematics Resources, when we have a whole number to be added to or to be subtracted from a fraction, we convert the whole number to a fraction that has the same denominator as the fraction that we have right here. So we need to write this negative 3 as a fraction that has the denominator of 8. So of course we say 8 multiplied by 3 is 24, and we put that over 8. This is by no means outlandish, because if we divide 24 by 8, we get 3. But of course we have them in a form that is easily manipulated, subtracting, or we may say adding, fractions with the same denominator. The constant value, negative 49 over 8, is the minimum value of the expression. It occurs when the expression inside of the bracket is equal to 0. So solving the equation x plus 5 over 4 is equal to 0 gives x is equal to negative 5 over 4. The minimum value is the constant value of negative 49 over 8, and it occurs when the one inside of the bracket is equal to 0, that is, when x is equal to negative 5 over 4. Notice that the expressions that we have considered so far have positive coefficients of x squared. If the coefficient of x squared is negative, then we will have to adjust our microscope. What is the difference? Quadratic expressions that have positive x squared coefficients result in curves that are U-shaped. The extreme points are at their lower ends and are therefore classified as minima. Quadratic expressions that have negative x squared coefficients result in curves that are umbrella shapes. The extreme points are at their upper ends, and they are therefore classified as maxima. Of course, maxima is the plural of maximum and minima, the plural of minimum. What are the algebraic implications? The variable part of the expression is the negative of a square. The negative of a square is always negative except when it is equal to 0. So there we have the negative of a square. So we have negative something squared. So that's the negative of a square, and that is always negative except when it is equal to 0. The variable portion is always subtracting something from the constant value. So let us take a look at a list of possible results. So we have when x is equal to 7, 7 minus 1, all squared plus 5. Of course, notice that is going to be 7 minus 1 all squared, that is going to give 6 squared, that is going to give 36. But now after we have squared the result and we get a positive value, which is with 36, we need to subtract. We need to also include this negative sign, so we have negative 36. So it is going to be negative 36 plus 5, and that is negative 31. This one, we have 5 minus 1, which is 4 all squared, that is 16. But of course, we have this negative sign right here, so it is negative 16 plus 5, and that is negative 11. And all of the values can be calculated. Let us look at this one. Negative 5 minus 1, that's negative 6. When we square a negative number, we get a positive value. So that will turn out to be positive 36. But we have this accompanying negative sign that will cause the overall result to be negative 36. So negative 36 plus 5 is equal to negative 31. Notice that the maximum value is 5, and of course that is equal to the constant value. This is when nothing is being subtracted from the constant value. So of course the maximum, notice that this has a negative 31, so this value, this number is less than negative 11. Negative 11 is less than 1. And if we take a look at the rest of it, we'll realize that the greatest value that we have here is 5. And the associated x value is when x is equal to 1, which will cause the content of the bracket to be equal to 0. So we may therefore conclude that the expression has a maximum value of 5, and this corresponds to, as we can see, an x value of 1. We may equate the content of the bracket to 0 and solve the simple linear equation that will verify that the value of x is actually 1. So of course inside here we will have x minus 1, so that is equal to 0. X minus 1 is equal to 0. So when we transpose that, we get x is equal to 1, and that is the value of x corresponding to the maximum value of 5. So we are going to be completing the square again, and we are going to take 3 as a common factor. As a matter of fact, we have a negative sign there, so we need to take negative 3 as a common factor. And of course, this one is also going to be affected. Next, we need to square half of the middle coefficient. So half of 8 over 3 is 4 over 3. When we square that, we get 16 over 9. Now, this 16 over 9 has no representation above. Therefore, we need to make an adjustment. However, this 16 over 9 is multiplied by that negative 3 that we have right there. So the 3 will cancel with the 9. We have a negative, because it's a negative 3, a negative 16 over 3. So to make our adjustment, we need to get rid of that negative 16 over 3, and that we do by adding 16 over 3. Adjust the whole number in order to have common denominators. As usual, I like to write this with the same denominators so that the addition process can be simple. So instead of 1 plus 16 over 3, we say 3 ones 3 and put that over 3, so we have 3 over 3. And of course, no problem, because 3 divided by 3 is 1. So it's just another way of writing it. And of course, we have 3 plus 16, 19 over 3, and in our normal custom of placing the negative 1 at the back, we put the positive 19 over 3 at the front and the other part of the expression, which is of course negative, at the back. The constant value 19 over 3 is a maximum value of the expression. It occurs when the expression inside of the bracket is equal to 0. That is, when x plus 4 over 3 is equal to 0. And when we solve that equation, we get x is equal to negative 4 over 3. The maximum value of the expression is 19 over 3, and it occurs when x is equal to negative 4 over 3. Here's another one. So we take 4 as a common factor in order to make the x squared coefficient inside the bracket equal to 1. And of course, this is going to be affected. The 5x is going to be affected. So next we need to square half of the middle coefficient. So half of 5 over 4 is 5 over 8. Square that, we get 25 over 64. And we are going to make our adjustment by saying we need to get rid of this 25 over 64 that was not there before. So we multiply by negative 4, and the 4 will cancel with the 64 to give 16. So we need to get rid of, remember that this is a negative value, we need to get rid of actually negative 25 over 64. So in order to do that, we have to do the opposite, which is plus 25 over 64. And then what do? We write this as a fraction with the denominator is 16 by multiplying 7 by 16 and putting the result over 16. And of course, turn the beta around. We have 137 over 16. So that is the maximum value, because the constant value of 137 over 16 is the maximum value of the expression. It occurs when the expression inside of the bracket is equal to 0. That is, when x minus 5 over 8 is equal to 0, which will give x is equal to 5 over 8. The maximum value of the expression is 137 over 16, and it occurs when x is equal to 5 over 8. And now we're going to be looking at extremum by using the axis of symmetry. The axis of symmetry is a line that divides the parabola into halves that are mirror images of each other. It therefore intersects the curve at the extreme point, whether minimum or maximum. It will serve us very well to remember that a vertical line has equation of the form x is equal to some constant like x is equal to 5, x is equal to 3, or x is equal to negative 2. If we go back to equation of a straight line, or probably both equation of a straight line and straight line graphs, we will understand that lines of the nature x is equal to 5, x is equal to 3, and so on are vertical lines. The axis of symmetry, being a vertical line, has a similar equation. So it is going to be similar to those equations that we have right there. The result can be very useful, as the x value in the axis of symmetry may be substituted into the expression in order to determine the y or f of x value that represents the maximum or minimum. So if a parabola has general equation that we are accustomed to, this general equation ax squared plus bx plus c, the equation of the axis of symmetry is x is equal to negative b over 2a. So let us use the axis of symmetry to find the value of x corresponding to the extreme point of a parabola and use it to find the extreme value. So there is our equation of a parabola. So we are going to correspond or develop a one-to-one correspondence with the general form of the quadratic expression. There we have it. So write down a template for the axis of symmetry, which is, of course, the axis of symmetry is x is equal to negative b over 2a. So the template will be x is equal to negative something over 2 times something that we have right there. So x is equal to, the value of b is 10. So negative b, so b goes right there, the value of b is 10, and over 2a. In this case, there is no coefficient, so the default coefficient being 1, we are sure that the a, or the value of a, is 1. So when we simplify this, we'll get negative 10 divided by 2, and that gives negative 5. So x is equal to negative 5. Therefore, the value of x at which the extreme point occurs, x is equal to negative 5, and this is going to be the equation of our axis of symmetry. In order to determine the extreme value, substitute this result in the original quadratic expression. So we're going to substitute that negative 5 into the quadratic expression. So here we have x squared, so negative 5 squared. Then we have 10x plus 10 times negative 5, and then plus 13. So we have 25 minus 50 plus 13, and the result is negative 12. Is this extreme value a maximum or minimum? How can we tell? The value of the x squared coefficient, which is a, is equal to 1. This is positive. For positive, we have what? The curve is U-shaped and the extreme point is a minimum. So, if a is positive, the curve is U-shaped and the extreme value is a minimum. The conclusion is f of x has a minimum value of f of x equals negative 12, and that minimum occurs where x is equal to negative 5. Let us continue, and we are going to be looking at another one. Let us write down the equation of the axis of symmetry, and there we have our equation of the parabola. So establish a comparison between the coefficients as usual. We have ax squared plus bx plus c, and of course we are going to put a template here, minus something over 2 something. So write down the template for the axis of symmetry. Now the value of b will go right there. The value of b is negative 12. The value of a will go right there. The value of a is 2. So in simplification, we are going to get negative of negative 12, which is positive 12 divided by 4. So when simplifying the result, we get x is equal to 3. Substitute the value of x into the original expression, and that is our result. 2 times all of 3 squared minus 12 times 3 minus 7. So we have square 3, we get 9. Multiply that by 2, we get 18. 12 3, so we have a negative 36, and our constant value is also included, and f of x is 25. So the function has a minimum value of f of x is equal to negative 25, and it occurs where x is equal to 3. We are sure that it is a minimum because the value of a, which is 2, is positive. Positive values of the coefficient of x squared will give us a U-shaped curve, and that will have a minimum value. So we have another one. B is 20, so we put the value of b 20. And of course, the value of a is negative 5, goes right there. So simplify the result. We have 20, of course, a negative 20 over a negative 10. So that is sure to give us a positive 2. Substitute the value of x into the original expression, and we have negative 5 times 2 squared plus 20 times 2 plus 3. And when we simplify that, we get 2 squared is 4. Multiply that by a negative 5, we get a negative 20. 20 multiplied by 2 is 40, and we have our 3 right there. So f of x is equal to 23. So let us be reminded of the special characteristic of the curve whose equation has a negative x squared coefficient. Maximum. So we have a curve with an x squared coefficient that is negative, is umbrella shaped, and the extreme point is a maximum. When the x squared coefficient is negative, the curve is umbrella shaped, and the extreme point is a maximum. We may therefore conclude that the extreme value f of x is equal to 23 is a maximum that occurs where x is equal to 2. The equation of the axis of symmetry did not come from outer space. As a matter of fact, it can be derived by completing the square on the general form of a parabola. Another useful formula can also be derived. So we are going to complete the square, and this by factoring off the a. So over here we have this thing being placed under the microscope. So if we take out a, that means this first term is to be divided by a, and this second term is to be divided by a. In the case of this first term, the a's will cancel. We have x squared, but nothing to cancel the a. In this one, we have bx over a. Right there. So, right there, we have a x squared plus bx over a plus c. So next we are going to take half of the middle coefficient and square the result. What is the middle coefficient? B squared over 4a squared. Next we are going to take half of the middle coefficient and square the result. The middle coefficient is bx over a. Now let us put that under the microscope also. So b over a, half of it means multiply by a half. So we get what? B multiplied by 1 is b, and a multiplied by 2 is 2a. So we have b over 2a. And we are going to square that. So we get b squared over 4a squared. b over 2a all squared, we get b squared, and we're going to square the 2, we get 4, and square a, we get a squared. So b squared over 4a squared. That is what we have right there. We notice that this one was not there before. So we need to get rid of this one, which is our newcomer to the expression. To get rid of this, we first need to multiply by a. So let's put that under the microscope also. So we need to neutralize the b squared over 4a squared, but it is multiplied by a first. So a multiplied by b squared over 4a squared. What happens? The a cancel with a squared, and of course we'll get a right there, and the b squared remains. So we're going to have b squared over 4a. So we are actually subtracting b squared over 4a. So a open bracket, or a to be multiplied by x plus b over 2a all squared plus c minus b squared over 4a. And we need to convert this to a single fraction. How is that done? That is done by what we have always done when we have a whole number and a fraction. We try to convert the whole number to a fraction that has the same denominator as a fraction, and that we do by multiplying by the denominator of the fraction. So we're going to multiply c by 4a, we get 4ac, and we put that back over 4a. So 4ac over 4a minus b squared over 4a, and that is what we have right here. When we combine them, they have the same denominator, so the numerators may be subtracted, and the result is what we have right there. Of course, we are going to see that expression again on this slide. So let us make good use of the derived expression. Remember that the constant value will represent the extreme value, which is the maximum or minimum. We are sure that the expression that looks somewhat sophisticated is a constant because the only variable is x, and it is not present in that part of the expression. The expression is used as a formula for the extreme value of a function. Therefore, f of x has extreme value that is given by f of x equal 4ac minus b squared over 4a. Students may use this formula to find the extreme value of a quadratic expression, although a blind dependency on a formula is strongly discouraged by Michael Wilson. The extreme value occurs when the variable portion is equal to 0, that is, when the content of the bracket is equal to 0. So when the content of the bracket is equal to 0, that is when the variable part is equal to 0, and that is when we have our minimum result, which of course is going to be equal to the constant value. So that part inside the bracket is equal to 0. Therefore, x plus b over 2a is equal to 0. Solving this simple linear equation gives, just put this on the other side by transposition, where it will acquire a negative sign. X is equal to negative b over 2a, and that we can identify as the equation of the axis of symmetry. Wait, there's more. Let us equate the expression to 0 and solve the equation. So we are equating that to 0 and we are solving this equation. And of course we are solving for x. First we need to get rid of this constant value to the other side of the equation. So that will go, our constant value will go to the right hand side, where it will acquire a negative sign. We may take the negative sign at the front on the right hand side into the numerator, and the sign of each term will be changed. So of course, when we take the negative sign up here, this will change to negative and this will change to positive. So let us now place the positive term to the front. We are always doing that. If we have a negative and a positive, the negative one is placed at the back and the positive one is placed at the front, like so. Now what do we need to do? We are going to take that expression that we had on the last slide and we are going to put it right there also. So what do we say? We need to get rid of this a. So we are going to divide by a on the other side, or we are going to multiply a in the denominator, which is equivalent to dividing it on the other side. So whereas we had 4a to begin with, now we have 4a squared. So the transposition continues by finding the square root of both sides, in which the square will be eliminated from the left hand side. So we may say that the square root and square are inverses of each other and will therefore neutralize each other. So we have x plus b over 2a is equal to all of this. Right. And do not forget that when the square root exists, it exists in pairs. The right hand side may be written with square root in both numerator and denominator. Do not forget that the square roots will always occur when they exist in pairs. So that is why we have a plus and a minus sign right there. So of course this we may say the square root of the numerator, square root of the denominator. And after saying that, we realize now that the denominator on the right hand side is a perfect square. So we may just simplify that denominator quite easily. So the square root of 4 is 2 and the square root of a squared is a. So we have the square root of b squared minus 4ac over 2a. So transpose the b over 2a to the right hand side. This is all that we have left to be transposed to the right hand side in order to make x the subject of the formula. So we transpose it to the other side and it becomes negative. And what do we know? The fractions have the same denominator and may therefore be written as one fraction. So writing that as one fraction, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And of course, most students will identify this as the quadratic formula. The quadratic formula was given to you in topic number 7, and that is in volume 1 algebra. Now we are not only aware of where it comes from, but we can derive it also. Keep on advancing with your mathematics. You may encounter some more pleasant surprises in the future.